So there are, of course, still a few problems with MIMO, as it hasn't been fully implemented in the MIMO technique. So the power consideration is still a fairly important restriction on MIMO, because more power is required when using multiple antennas. Now, power, of course, is already severely limited on smartphones, as you have to recharge your phone daily after just moderate use. Adding an antenna would significantly reduce the battery life of a phone, so that without an increase in battery or an improvement in battery technology, a phone with multiple antennas running all the time may need to be recharged multiple times per day, which is not feasible in today's society. And because of this, manufacturers are against the mandatory use of multiple antennas, as they would have to increase their battery capacity or reduce battery usage in other parts of the phone. Even still, specifications are being developed that require 2 antennas, but also encourage 4 antennas, which would give you a 4-fold increase in capacity. Additionally, carriers are concerned about upgrading CISO base stations to MIMO, as they feel that it would require more radio frequency cables and the introduction of a power amplifier placed at the antenna to increase the SNR at the transmitter stage. Now, this power amplifier would have to be placed on the pole, which would lead to increased maintenance costs. Alright, so before I move on to MATLAB to talk more about the code and run a few more simulations, we'll wrap up this presentation. So MIMO is currently the front runner for increasing the throughput and data rate in next generation wireless communication systems. And in fact, it is already in use to an extent in LTE through multi-user MIMO. A MIMO provides a much higher capacity than CISO and also MISO, with a minimum increase of 2x. It's exciting to note that MIMO has hit the market, and so we can expect more devices to begin using this technique in the near future. And hopefully, in the next few years, faster data will become mainstream. But before this can happen, some issues still need to be resolved, including the power considerations at the receiver or mobile device, and the upgrades that have to be done to the base stations. Okay, let's move to MATLAB. So on the on the left, we have my MIMO comparison function. So I'll just go through each line really fast. I just defined the 2 equations first for just a CISO system, and secondly for the MIMO system, and you can see that they're the same except for the addition of the M term. So first we generate our signal to noise ratio, convert it from decibels, and then we can calculate our capacity for the CISO just from implementing the Shannon-Hartley theorem. Next, we look at our first MIMO system, and the first thing we do is calculate the number of streams, which is, as mentioned previously, the minimum number of either the number of receiver antennas or the number of transmit antennas. Next, we generate a random transmission matrix, as this would change depending on the implementation in the field. So, and then finally we calculate the capacity for a MIMO system, which is simply the equation listed above. I also included a maximum ratio so we could get a better quantitative comparison of the increase in capacity over MIMO or over CISO. And we do the same for a second system and a third system. And then finally we plot all the different data and create our legend, labels, and title, of course. So now move over to MATLAB and run this script for a few different data sets. So let's try. Start with just the square MIMO. Which we see here. We have our baseline of about 16. The 2x2 is about 32. 3x3 is about 53, 54. And finally the 4x4 is around 65, 66. Now it's important to note that these increases are not exactly linear, they're not exactly equal to m, because each transmission matrix is regenerated since they're different size matrices. But still, looking at the output of the maximum values, we see that they're quite close to the expected. So for the 2x2 we have an increase of 2.02, the 3x3 3.14, and for the 4x4 an increase of 4.05. Alright, and finally we'll take a look at a larger scale of some MIMO, square MIMO systems, just to get a better idea of how increasing the number of antennas really gives you a large increase in capacity very fast. So you can see here for a 125 square MIMO system, we get an increase in capacity by around 122, as you can see down below. Now this implementation just multiplies by 5 each time, so we have CISO and then 5 by 5, which is almost the same, it seems, as the CISO, then 25 by 25, and then 125 by 125. And what was mentioned in class a long time ago was that there are plans to one day have 1,000 antennas in a single system. So you can only imagine having a 1,000-fold increase in capacity. So that's what I'm excited to see in the future. And I hope you enjoyed learning a little bit about MIMO technologies and where they're going and where they are now, and also being able to compare the capacities to get a better understanding of how far they can go. Thank you.